Hello and welcome. I'll be talking about Six Sigma quality today. And in order to have more clarity about what quality is, let me show you two pictures, which is one is a Mercedes, the other one is a Ford truck. Now it's very intuitive to think that Mercedes would have a superior quality than Ford, because the very definition of quality is how good a thing is. However, it is just one dimension of quality, which we call as design quality, that relates to features. The other quality, which is how that feature is produced, we call that as conformance quality. Six Sigma is relevant to conformance quality, the way a feature is produced. Now each time we produce a feature, it may not be exactly the same as the earlier feature, or the output may vary slightly. It would be similar, but there will be some variation within the output. Now the key question that relates to Six Sigma quality is, are those variations acceptable? In order to determine if those variations are acceptable, we have plotted an output of a process, and we would resort to the normal distribution so as to establish the acceptable limits, which are normally at 3 plus minus 3 standard deviations. Now from normal distribution, we know that plus minus 3 distribution correspond to an output of 99.73%. that is, if a product is produced 100 times, 99.73 times it would have an acceptable quality. But if we increase the opportunities or the output to a greater number, we would find out that this 3 sigma quality levels would not be sufficient. For example, if there is 1,000 landings at an airport, 2 plane landings would not be safe. Similarly, we'll have 2 million documents lost, so many checks, because the number of transactions has increased a great deal over the years. The answer to that is that we have to move beyond the percentage acceptable limit and with regards to quality, and move on to something called defects per million opportunities. So this is what a 3 sigma process variation is, that is 6,800 defects per million. But if we keep reducing the inherent variability in the system and ultimately reach a 6 sigma process variation level, the allowed defects would be just 3.4 defects per million. That's the ultimate aim of 6 sigma process capability. Thank you.